Okay, so now we're going to be talking about solving trigonometric equations, and now we're going to be doing some factoring. Well, in algebra, one of my favorite topics is factoring. I really do love factoring. It's kind of stress relieving. I mean, maybe you think that's weird, but I think it is. But anyway, let's take a look at this one. It says 2 cosine squared of x minus 7 cosine of x plus 3 equals 0. So I'm not going to worry right now that this is a trigonometric equation. All right, I'm going to relate it to algebra. Okay, so I'm going to say, well, let's pretend, let me take that back, that it's 2x squared minus 7x plus 3 equals 0. Okay, so this is a quadratic, and I'm going to write it out over here on this side. I'm going to work it out. 2x squared minus 7x plus 3 equals 0. All right. Now, I teach factoring in a different way maybe than you might have seen. But I do what I call the modified AC method. So you take your A, you take your C, and you get 6. And then you want the factors of 6 that in this case add to give you negative 7. Well, I've got 1 and 6. I've got 2 and 3. What are the signs so that I can have a negative 7? Well, in this case, the two numbers have to be the same sign. They're both either positive or both either negative, because they must add to give you negative 7. So in this case, it's going to be 1 and 6, because 1 plus 6 is 7. But in this case, it's going to be negative 1 and negative 6. So that's what we're looking at there. Now, I teach, again, like I said, factoring in a different way maybe than you've seen. I write negative 1, I write negative 6, and then I divide by the AX term. So in this case, A is 2, so I'm going to divide by 2x here. So 2x and 2x. And so I say, okay, well, check to see if you can reduce the fraction. And negative 1/2 doesn't reduce. But negative 6 over 2 does. You get negative 3 over 1. So this I'm going to write as negative 3 over x. And then I tell my students, I say, okay, right after that, then it's just bottoms up. Bottoms up. What do I mean by that? Okay, well, 2x minus 1 will then get multiplied by x minus 3. That's what I mean by bottoms up. If you look, the 2x comes right up beside the negative 1, just like it does here. And the x comes right up beside the negative 3, just like it does here. And these are our two factors, and we set that equal to 0. All right. So this is what we're getting at. So this right here is going to help in solving this equation, because it's actually quite similar. We're going to, instead of saying x here and here, we're going to say, well, cosine x. Cosine x. Okay, so we're going to use our knowledge from this step back over here to answer this question. So let's take a look and let's write it. 2 cosine x, okay, minus 1, and cosine x minus 3, and set that equal to 0. So now we apply the 0 factor property. We're going to say 2 cosine x minus 1 equals 0. And then the other one we're going to say is the cosine of x minus 3 equals 0. So I'm going to solve this one first, right here. And I'm going to say, well, the cosine of x just equals 3. Well, think about the unit circle for a bit. Okay, you think about the unit circle. There's no place where the cosine will equal 3. So this one right here is actually not a solution. So in this case, for this part of the equation, there is no solution. So this is out of the question. All right, but this one right here on the left, this can be solved. You add 1 to both sides. You get 2 cosine of x equals 1. You divide both sides by 2, and you get the cosine of x equals 1/2. Now, if you remember anything about the unit circle, all right, and I don't have a unit circle handy, but you'll have to look. Think about the quadrant and the coordinate system. Okay, we're going to write in here the fact that all students take calculus. So let me switch inks here real quick. All are positive in quadrant 1, and in quadrant 4, cosine is also positive. So our answer is going to come from both quadrant 1 and quadrant 4 because we're looking at the cosine. So let's think about this for a second. Where does the cosine equal a positive 1/2? Okay, so you're going to look at the unit circle and you're going to see that it happens, and let me write that over here. It happens at x equals pi over 3. All right, so look at the unit circle. I don't have one with me right here, just a second, but and then the other one is at 5 pi over 3. Okay, so that's where it would be anyways. All right, and you've got two values. Now remember that cosine, you could do a revolution of 2 pi radians. So to write generalized answers here, we would say, well, x equals pi over 3 plus 2k pi and 5 pi over 3 plus 2k pi. So again, you want to go back and you want to reference this. Go back and take a look at your unit circle, all right? And that will help you out so much, okay? Let's go ahead and take a look at another example, and I really like these quadratic types. Let's go ahead and take a look at another example, and we're going to have to do a little more fancy footwork here in terms of using the identities, because we need to, in this case, I've given a suggestion that we probably need to use a Pythagorean identity. But let's go ahead and take a look. Okay, looking at this one, it says 1 plus the sine x equals 2 cosine squared of x. Well, the trick is that you want it all in terms of all sines or all cosines. This one that's not the case. Okay, that's not the case at all. So what we're going to do, I'm going to make use of this Pythagorean identity here. And I'm going to say, okay, let me move this sine squared to the other side. And I'm going to say cosine square x equals 1 minus the sine squared. Okay, so just as simple as that. And now I'm going to come back over here to my equation, and I'm going to make this substitution here. And I'm going to say, well, 1 plus the sine of x equals 2 times 1 minus sine squared. Let me fix that. 1 minus sine square of x. Okay, looks something like that. Now I'm going to do some simple distribution here. I'm going to get 1 plus the sine of x equals 2 minus 2 sine square of x. And I'm going to do my best to eliminate the right hand side, move everything to the left, so that I can get a quadratic that's equal to 0. So let's go ahead and do that. Minus 2 minus 2, and then I'm going to add 2 sine square. Add 2 sine square. Now it's not going to combine with this. I need that to be very clear. All right, this cancels, this cancels. In descending order, we have an equation that looks like this: 2 sine squared of x plus the sine of x, and 1 minus 2 is negative 1. And we're going to set all of that equal to 0. Okay, so then again, we've got some more little work we could do, the algebra behind this. This right here looks a lot like this: 2x squared plus x minus 1 equals 0. Okay, we are looking for the factors of 2 times negative 1, which is negative 2, with a, in this case, difference of positive 1. There's no number written in front of that variable x, but we know it to be 1. So 1 and 2 are the only factors, and the signs are going to be negative 1 and positive 2. Now, just as in the previous example, I write them out: negative 1, positive 2, and I divide them again by this ax term. In this case, it's 2x. So 2x, 2x. And as I said before, you try to see if you can reduce. Here it can't be reduced. Here it can. You get positive 1 over x. And then just as before, I said bottoms up, bottoms up. So you get something that looks like this. 2x minus 1 times x plus 1 equals 0. So in this case, we're making the substitution that the sign corresponds to this value for x. So I'm going to write 2 sine of x minus 1 times the sine of x plus 1 equals 0. Okay, and now applying the zero factor property, I can say, well, let's see here, 2 sine x minus 1 equals 0, and then sine x plus 1 equals 0. This one right here on the right is easier to solve. Minus 1 minus 1. Where does the sign, in other words, equal negative 1? And on this one, you add 1 to both sides. This cancels. 2 sine x equals 1. Divide both sides by 2. In this case, where does the sign equal 1/2? Okay, so these are the two things that we're trying to solve here. Let me move the screen, adjust it a little. All right. The sign equals negative 1. The sign equals half. Okay, again, you only need to take a look at your unit circle. Okay, well, there's only one place where the sign equals, in this case, negative 1. And so that's really easy to consider. That's just at 3 pi over 2. All right, so that's the simple answer. But the generalized answer is that, well, you know that x will equal 3 pi over 2 plus every 2k pi revolutions. So for every 2 pi radians that you add, you're going to always end up at negative 1, assuming that you start there at 3 pi over 2. So that's one generalized solution for this. The other one is, where does the sign equal 1/2? Again, if you're looking at a unit circle, you know something like this. You know that all students take calculus, and so you know that's going to be in quadrant 1 and 2, where the sign is a positive 1/2. So you look at your circle again. I don't have one handy, as I mentioned before, but you look at it, it's pi over 6, and the other place is at 5 pi over 6. So quadrant 1 and quadrant 2 there. Okay, so let's see here. Pi over 6 plus 2k pi is one of them, and the other one, as I mentioned, 5 pi over 6 and then plus 2k pi. So look something like that, and there are actually 3 solutions to this quadratic. It's a really interesting item. I'm thinking it's interesting because you're dealing with a quadratic, and normally there's only a maximum of 2 answers, but this one is different because, again, consider we're talking about trigonometry and trigonometric functions and really trigonometric equations. So given that you're talking about the numbers of revolutions and things like that, there's actually an infinite amount of solutions, but these are the generalized ones at any rate. So I hope you understood what was going on with these quadratic type of equations, and good luck.